This topic discusses the expression to locate the centroid of an area. Center of gravity is a point at which the entire weight is assumed to be concentrated. In case as in volume, area or line, this is termed as centroid. Force of gravity is the resultant of many great forces. The first moment of weight is defined as the product of the elemental weight multiplied by the perpendicular distance of the element from the reference axis. Let us consider a homogeneous plate of a uniform thickness T, area, and density. If we take infinitesimally area dA, then its weight will be the differential weight is equal to the density times the thickness times the differential area times the gravity. Hence, we have to integrate the equation to obtain the weight of the entire plate. The first moment of weight of this infinitesimally small element about the x-axis is given as the product of its weight and perpendicular distance from the x-axis. By the principle of moment, the y-ordinate of the location of the center of gravity is determined as the location of the center of gravity with reference to the x-axis, which is y bar, times the weight, which is equal to the density times thickness times the gravity times the differential area times the y. So we can cancel this constant. Since the density and thickness are constant, they can be taken outside the integral sign. Therefore, the location of the center of gravity with respect to the x-axis is given as y bar equal to the integral of y dA over the area. With reference to the y-axis, the centroid is equal to the integral of x dA over the area. Let us determine the centroid of a rectangle. Consider a rectangle of base length b and height h. If we take a thin strip parallel to the x-axis at a distance y from the x-axis and of infinitesimally small thickness dy, then its area is given as the differential area equal to b times dy. The area of a rectangle is given as the integral of the differential area with a limit of 0 to the height. By integration, area is equals to the base times the height. As each point on this strip is at the same distance, y, from the x-axis, we can take moment of area of the strip about the x-axis as the distance times the moment about the x, which is equal to y times the differential area, which is equal to yb dy. Therefore, the first moment of the entire area about the x-axis is given as which is equal to the base times the height squared over 2. The y-ordinate of the centroid of a rectangle is given as by substituting the values, the centroid of the rectangle is h over 2 with respect to the x-axis. In a similar manner, we can consider a vertical strip at a distance x from the y-axis and of infinitesimally small thickness dx, and obtain the x-ordinate of the centroid as thus, we can see that the centroid of a rectangle lies at the midpoint, or in other words, at the intersection of two diagonals. You are able to derive the location of a centroid of a rectangle. You can try solving for the centroid of various regular geometric shapes like triangle and circle. Let us locate the centroid of a composite area. The given angle section can be considered to be made up of two rectangles, both of dimension 8 cm by 2 cm. Let us consider the bottom fiber as area 1 and the upper fiber as area 2. Let us make a table. The subscript I represents the individual shapes or area of the composite area. The bottom area represents 1 and the upper area represents 2. The area of the first rectangle is 8 times 2, which is equal to 16. And the upper area is 2 times 8 equal to 16. The centroid of the first rectangle is located at the center, which is 8 over 2. The centroid of the second rectangle is located on its center, which is 2 over 2 equal to 1. The centroid of the lower rectangle is and the upper rectangle is 2 with a 2 cm height plus 1/2 of its height equal to 6. Multiplying the individual area with its centroid, we get 64. 16 times 1 is equal to 16. Multiplying the individual area by the y bar, we get 16 and 96. By using the formula, x bar is equals to the summation of the individual area times its centroid over the summation of the area. So let us determine the sum of the area. So the location of the x bar or the centroid of the composite area with respect to the y-axis is 2.5, and y bar is also equal to 112 divided by 32, which is equal to 3.5 cm.